All right. Yes, so this is velocity. Here you have 3 by 2. Here you have plus 1. So it's like x to the power 3 by 2 by x. So this will also give you x to the power half only. Half only will be left. So now again forget this dq because this is also not of your importance right now. What is important to you is v and x. See how they are proportional to each other. V will be inversely proportional to x to the power half. So V is directly proportional to x to the power minus half. This is how you have to relate the quantities. Do you see this portion, not till this part? Every question will be similar. Till here, all of you should remember. Whatever modifications will be there, you have to manage it through here. Using your formulas, using your knowledge. Velocity we didn't have, so we have to get velocity somehow. So option is B option. B option is the correct option. Heather, your doubt is clear? Heather, you there in the class? Heather Ali Khan?
Yes, ma'am. Yes, ma'am.
Okay. So note it down. Wherever you people are not able to understand, let me know. Then we'll start with the revision of current electricity. First, we'll do the theory part. See, in today's class and tomorrow's class, both the class we'll do current electricity only. In your test, that is their Friday mock test, class, current electricity will only come, but the circuit part won't come. Rest of the formulas part, that will be included. Circuit part won't be there. Series, parallel, any type of circuit, Kirchhoff's law in the circuit, those questions will not come. Only the basic theory of Ohm's law, resistance, only basic these will come on Friday. Note it down, we'll start with current electricity. Yes, class. Now, see, from current electricity. So basically, DC circuits, as I've told you, that I'll do separately. DC circuits, will take a separate class. We'll just practice circuits in that class, and that will be not a part of syllabus for this Friday. I'm specifically telling this because do not practice your or do not waste your time in practicing the circuits. All right, practice your times in these, remembering the formula and application of it. So basic quantity in current electricity is electric current. Electric charges we had seen in electrostatics, right? We had seen so many phenomena due to electric charge. Electric force was there due to Coulomb's law. Electric field got existed. Then Gauss theorem was there. Electric potential got existed because of the charge, right? And because of charging, discharging, we had capacitors also. So everything was based on charge. But one thing that was specific was that charges weren't moving. Now, as soon as the charges begin their motion, we say it's current. That is rate of flow of charges. So how to choose the direction of current? Direction is exactly same as that of positive charge, but if you have a negative charge like electron, so definitely remember to reverse the direction. So we can call it as a vector quantity or a scalar quantity because it has a direction, right? But see, remember, electric current is the only scalar quantity that has a direction. The reason behind this is that because electric current doesn't obey any vector laws, and to be a part of vector quantities, there has to be a need to follow all the vector laws, and which is not satisfied by electric current. All right, that's why it is a scalar quantity only. So no need to remember that direction in the sense for you will take parallelogram law for addition of current. No, directly add for positive, subtract for negative. The rest of the laws and all you people are aware of. Now see, so yes, this is how you use the basic formula. Delta Q by delta T, that is average current. Now when to use delta Q by delta T, when to use dQ over dt. See, when two quantities are given as in duration, you have a starting, you have an ending. Like if I ask you to calculate the current between 2 p.m. to 4 p.m. or calculate the current between 2 seconds to 3 seconds, right? So here you will use average current. You will take the difference of the charge and then divide it by the difference of the time. And then you have instantaneous current. In instantaneous current, you choose differentiation when you have a particular time instant, as in calculate the current as 0.67 seconds, calculate the current as 0.0089 seconds, like this at a very particular instant if I give you. So this is how to differentiate between these. The rest of the question part is easy. Graphs are also basic. See, yes, next quantity is drift velocity. So drift velocity is this derivation is not very important to you, but just remember what is drift velocity, and the formulas will be associated with drift velocity. Questions are there. And 21 also question came. Last year's paper, if you see, last to last year, 21, it was just matching of formula, and I'll start with that question only. It's a very easy question so that you can see. So velocity with which electrons drift, basically every electron is having its own unique velocity with which it's drifting, it's moving. And when I ask you to tell me the velocity of the conductor, which velocity will you define? Velocity of the first electron, second electron, third electron, which electron? Obviously, it's difficult. So what we take the average values of all the velocities by all the electrons. And that average value, this is known as drift velocity. So formula of drift velocity, you should remember, this formula is sufficient. Vd is equal to minus E tau by m. Vd is the drift velocity. Small e is the electronic charge. Capital E is the electric field. Tau is the relaxation time. And m is the mass of electron. Class, pay attention to this mass of electron because this becomes confusing whether it was mass of electron or it is mass of conductor. All right. Here, till other quantities, you will be able to tell me the value or what is that quantity, you'll be able to define it. But when it comes to divided by m, in the exam, if mass of conductor and mass of electrons both are mentioned, then it becomes a little difficult to tackle whether it was mass of electron or conductor. So remember, it's always mass of electron in drift velocity formula. Another important formula is this: I is equal to NEAVD, which connects the relationship between current and drift velocity. From here, it seems that current is directly proportional to drift velocity, but this isn't the case. Even whatever amount of charges enter will be exactly the amount of charges that will leave. So is it depending upon their velocity? No, it's just depending upon the number of charges. So whatever is the diameter or area of the cross section, current is independent of it. But drift velocity depends upon area. If small narrow portion is there, the electrons will try to do what? A very small area, so very force will occur. With a high velocity, electrons will move. If area is narrower, they'll move. If area is wider, they'll move freely with a less velocity. So it is inversely proportional to it, this relation. These theoretical statements based questions will be asked. Then a very important law, but very easy law, that is Ohm's law. This is important for your Friday's test as well. See, Ohm's law is what? Ohm's law basically, this says that if temperature and pressure, these two quantities remain same, so whatever is the potential, it is directly proportional to current. Now, potential is directly proportional to current. If you remove the proportionality sign, you get a constant, that is I. So V is equal to IR, and R is the resistance. And class, always remember, whenever you are getting questions on graph, whether it's VI graph or IV graph, if it's VI graph, directly take tan theta, you will get the resistance. But if it's IV graph, then tan theta won't give you resistance, it will give you 1 by R. So if in the question IV graph is given and you are asked to calculate resistance, do remember to reciprocate it. Otherwise, in the option, 1 by R would also be given and R would also be mentioned. So you might choose a wrong option. So always remember, whether it's I versus V or V versus I, just check before solving it. So this is the electric current portion. Then coming in detail about the resistance and resistivity. So resistance is what? Resistance is basically, we had seen the formula of resistance, V by I. So one formula is V by I. Another formula that is not used so much, this is ml divided by Ne square A tau. M is again the mass of electron, not the conductor. L is the length of conductor. N is number density. This is the number density. E is electronic charge, 1.6 into 10 to the power minus 19. A is the area of conductor. And tau is the relaxation time. What is relaxation time? See, whenever two electrons collide with each other, and the electron is about to collide with the next electron, between that transition, there's a very, very small relaxation time where the electron isn't colliding with any of the entities. So that very small duration time is known as relaxation time. So again, for every electron, there will be independent values of relaxation. How do we sum up? So we take the average value. So average values of all the relaxation time is known as average relaxation time. So this is basically average relaxation time. Now resistance depends upon 4 quantities. Resistance is directly proportional to length, inversely proportional to area, and it depends upon nature of material and temperature. Temperature one is very important. You have a full-fledged formula also, and many questions have come from resistance dependency on temperature. It depends upon the nature of material. It depends upon the nature of material also. It means that, for example, if you have one particular type of material, you will be having the value of resistance for it. Like for brass, you will be having a certain value of resistance. For zinc, you will be having a certain value of resistance. For iron, you will be having a different value of resistance. So as you will be changing the material, values of resistance will change. So two formulas we had seen, V is equal to IR. From that, you have R as V by I, then ml square, ml by Ne square A tau. Last formula is this. R is equal to rho L by A. If you remember resistance well, resistivity becomes easier. All right. So R is equal to rho L divided by A. So rho is resistivity. Resistivity is what? It can be defined as resistance of a unit length and unit area of cross section. So just in resistivity, it doesn't depend upon length and area. So same formula, but without L and N, L and A. Then you have few quantities which you have to remember: conductance, conductivity, mobility, and all. Conductance is inverse of resistance. We represent it through G. So if resistance is R, conductance will become 1 by R. SI unit is ohm inverse. Similarly, inverse of resistivity is conductivity. You get the value of resistivity the way you calculated, use your formulas and reciprocate it, that will give you conductivity. Current density is very important. Current density, out of all these small little topics, current density is the most important topic for your calculations as well. And separate formula also. So current density is simply current per unit area. And microscopic form of Ohm's law is current density is equal to conductivity multiplied by electric field. So if anywhere current microscopic form of Ohm's law is mentioned in your paper, use this formula. Current density is current per unit area. Conductivity is 1 by resistivity. Electric field is kq by r square. Last, you have mobility. So mobility is drift velocity per unit electric field. So mobility is the ratio of drift velocity and electric field. Yes, these graphs also can come to you from semiconductors also, this is related, and from current electricity also this is related. If you have a conductor, graph will be somewhat like this, where initially it is non-linear, but after crossing 0°C, it becomes linear. For alloys, it is the same thing, but it's just that variation is very small. You can see only this much of increment is there. But for semiconductors and insulators, it is inversely proportional. Means if you increase the temperature, resistance will decrease, opposite will occur. So proper hyperbola you will get. Superconductors are not important. It's just that superconductors have such type of graph where at a critical temperature, the value of resistance remains the same. But as soon as the critical temperature is crossed, it increases exponentially. So for superconductors, this is not so very important, but just in case in your entrance, if it comes, you should have an idea. And this is the formula resistance. RT is equal to R naught 1 plus alpha T minus T naught. Now RT is what? RT is the resistance at room temperature. Resistance at a certain temperature, random temperature. R naught is resistance at room temperature. 1 plus alpha. Alpha is coefficient of resistance, coefficient of resistivity. Then T is temperature, for which R's value we had written, and T naught is room temperature. So same thing. At a certain temperature, room temperature, resistance at temperature T, R naught resistance at the room temperature, alpha temperature coefficient of resistance. This all you should know. And yes, for conductors, value of alpha will come positive. For alloys also alpha will come positive, but it's just that the magnitude will be small. And semiconductors and insulators, alpha will become negative. That's it you have to remember from here. And lastly, for terminal potential difference, let us discuss that also, so that we will be left with just practicing of the questions. Some questions we'll do, rest of the questions we'll complete it tomorrow. I'm again repeating, those who were not present in the initial part of the class, circuits will not come in Friday's test. Friday's test syllabus is current electricity without circuits. So DC circuit won't come, all these questions will come which I'm discussing. Now see, you have three topics, very small topics, which are left, that are internal resistance, EMF, and terminal potential difference. Now, what happens is that you have a cell is having electrodes. Electrodes are dipped into electrolytic solution. Now, when the circuit begins, the circuit flows, what happens is that these ions and electrons, these electrolytic solution, and the electrodes which are dipped into this electrolytic solution, all of these also offer resistance, and this occurs within the cell, inside the cell. What do? We just connect the cell in the circuit. No, but what is happening within this cell is actually an expansion of this. So this you would see study in detail in your chemistry also, electrochemistry. You have a lesson, you have all the, I think, formulas also to calculate how does this phenomena occur. So exactly that same thing is applied here. But we are not concerned with which ions are moving. We are concerned with the resistance that it is providing. And that resistance is known as internal resistance. So resistance of the battery within itself is known as resistance, internal resistance. And the resistor which we connect by ourselves in the circuit, that is known as external resistor. This is the difference. And EMF is what? See, EMF is electromotive force is its full form. So it's just a misnomer. It's not a force. All of you must be knowing this. It's a maximum potential difference that is applied across the terminals of a cell in an open circuit. So basically you can understand this in the sense, you have internal resistor, this cell must be having some internal resistance. Whatever is the EMF, that whatever is the potential difference of that internal resistor, that is known as electromotive force, EMF. And whatever is the potential difference across the external resistor, that is terminal potential difference. So for closed circuits, you use terminal potential difference. For open circuits, you use EMF. This much of theory is very much enough for your NEET. Just remember these formulas will be used. So total resistance will be what? E is equal to R plus R. Now see class, what is this R? This R is the external resistor that is connected along. But do we always just put one resistor? Sometimes it happens we place the resistors along with series and parallel and all these connections. So what do we do? So basically what you have to do, this entire part is known as external resistors. So you have to resolve it, find the R equivalent. This is basically R equivalent that will be used. And potential difference, see, if this is the internal resistor, so potential difference will be how much? Potential difference will directly be IR. And if this is external resistor, so potential difference will be I into capital R. Right, current is I, depending upon the resistor. If it is external resistor, IR. If it's internal resistor, I into small r. Now, current is E by R plus R. Potential is I into R. I was E by R plus R multiplied with R. And this is also very important formula, terminal potential difference, which says that EMF minus potential difference across internal resistance. EMF, whatever is the EMF minus potential difference across internal resistance. So V is equal to E minus IR. This formula also, this will be used. So I think most of the theory part we have discussed. This is charging and discharging. This also you should see. See, V is equal to E minus IR will be only valid till when the discharging of cell occurs. Usually we use this. If in your exam, it is specifically, the question is specifically mentioning that charging of cell is occurring. That is, current is flowing into the cell, not from the cell. Current is moving into the cell. Then you will put a plus sign. That's it. That's all what you should know about current electricity's theory part. Rest of the series, parallel, Kirchhoff's law, potentiometer and Wheatstone bridge devices also we'll see along with the circuits also. Only. Let's see the questions. Let's practice some questions at least from this. So same thing, I'll write down the question. You will note it down. You will practice it and send me your answers. And please at least try it once, and only you will be able to understand the solution better. And again, I'm repeating. See, I hope you know the pattern of physics. Physics, what on in every subject. You have 50 questions total, out of which you have 35 and 15. These are compulsory questions. You have to attend all of these. As in, whatever you have no option. If you do not attempt any of the question, marks will be deducted. Right. So 35 questions are compulsory. These, out of these, you just have to, this is optional. That is, you have to attempt any 10. So that makes 45. All right. So 4 plus score for every correct answer, -1 for incorrect, and 0 for not attempting. So instead of attempting an incorrect answer, it's better if you leave it. So out of these 35 questions, if you are not sure about any question, then leave it directly. Leave it. And try to attempt it fully with surety, because otherwise if you attempt it wrong, then these 4 marks also will be gone. Plus -1 will also be there. So total 5 marks loss will be there if you attempt a question. And out of these are optional. So whichever 5 questions you think you are not able to attempt it, leave that. And this is valid for every subject, even for chemistry, same thing. For biology also, you have same thing. For zoology and botany, it is divided. Same thing occurs. So 45, 45, 45, 45. Likewise, you have to do that, will make it 180. And total score will thus be 720. All right, so 35 questions are compulsory. Compulsory in the sense that it's not mandatory for you to attempt all the questions. And if you leave a question, you won't get marks. This isn't the case. It's like there isn't any option. 35 out of these 50, 35 questions have been separated. Just the 5 questions that are extra, no, that are present, they are present within this section B. So section A and section B. Section B, you should be attempting it well with your knowledge, whichever question you have to attempt. So choose the portion smartly, whichever questions you have to, because otherwise if you attempt it negatively, it's like if 20 marks is now you're getting 20 marks, let's say. Fine, 4 questions you have attempted correctly, or let's say it in this sense. 4 questions you have attempted correctly, even 1 you have attempted incorrectly. Total questions were 5. Let's say total questions were 5. So 5 into 4, that is 20 was the total marks. Now see, if you had attempted the question correctly and left this incorrect one, you would have got 4 into 4, that is 16 on 20, right? But now what is happening? 4 correct with this 1 minus. Understood? So from your side, you have attempted 20 marks, right? From your side, you have attempted 20 marks. You have attempted all the 5 questions. So you should get 20 marks. But what will be the result? The result will be 15. So it wouldn't be just loss of 1 marks. That is, you won't get 19. Those 4 marks also of that question will be gone. So that's what I was saying. This is the total loss of 5 marks. You will think you are getting 20, you will get 15 because of just one incorrect question. So that's why be sure about it. So any doubts, other student also who have any doubts regarding the pattern of the paper or which attempting strategies, please let me know. And again, do not waste your time in studying every minute details of theory. You do not have time for that. Just previous year questions and JEE AI EEE questions, these are sufficient for you. And do try, whenever I write the question, at least attempt it in the class. Whatever answer you're getting, if you're getting your option isn't matching with your answer, you're getting something different answer, and it's not present in all the 4 options, then text me, I'm getting this answer. At least I would know that you all are at least trying it by your side. Okay, so note it down. Okay, with a very easy question, I'll start. So I'll not write everything. It's just that you have to match the column with the formulas. So just formula based question is there. Yes, class, this is an easy question. Do one thing. Let's say this is A, B, C, D, and this is 1, 2, 3, 4. Now tell me the order of 1, 2, 3, 4. Just tell me the order, exact order, which should come in front of this A, B, C, D. This much you all can do. Like 3, 2, 1, 4, 1, 2, 3, 4, whichever is your answer. Like this. Now that send me in the chat column. So only Anna has tried this question. Others haven't tried. Abhinav, Heather, Aram, Samaira. Yes, Aram has also tried. So Anna and Aram have tried. So see the order. Yes, Aram. I think just Anna, one place you have missed. Aram, your answer is right. Drift velocity. Just now we did it. E tau by m. Didn't we do this? So A was 3. Now electrical resistivity class. See, for electrical resistivity, you have the formula divided by NE square by rho. This is itself resistivity. NEA VD you have, and you have E divided by J. So see, VD drift velocity EE tau by M. This is EE tau by M drift velocity. Electrical resistivity. Resistivity is M by NE square tau. So from here, relaxation time will become M by NE square rho. So your relaxation period, right, that will be first part. So relaxation period, this will be this. All right, so A is 3, C is 1. Now, C for current density, no? Okay, this A shouldn't be there. Otherwise, this is the formula for current. For current density, this will be any only. Please make a correction class. I think by mistake I had written A. So see, formula of current is NEA VD. Current density is current per unit area. So that will become NEA VD divided by A. That is NE VD. So current density will become NEVD. Now electrical resistivity, I have told you microscopic form of Ohm's law, sigma E. So sigma is J by E. So resistivity will become E by J. That's how. Class, let's do one thing. For Friday's test, no, a combination of cells and all, but basic resistance let's have with us. Basic resistance circuit, no, series and parallel, that I'll practice tomorrow also. Let's include that, because questions on resistance and Ohm's law will be difficult for you to practice when you relate it with NEET, because in NEET questions are in relatable form, right? If you have series and parallel, that will be related to your external resistor, and that will be used and related to your internal resistance formula. And so in the terminal potential difference likewise. So basic 1 by R is equal to 1 by R1 plus 1 by R2. R1 is equal to R1 plus R2. That, let's include that. Otherwise, separate circuits, combination of cells using application of Kirchhoff's law, heating effect, that will be dealt separately in the next test. So these questions I'll practice. I'll make you practice today also. At least we have time, 10 to 15 minutes we can give it more. So this is the solution. I'll write down the other question, note it down. So class, the theory part remains the same. Basic theory part remains same, that if you have parallel connection, for parallel connection of resistors, 1 by R equivalent is given by 1 by R1 plus 1 by R2, like this. And for series connection, resistance is given as R equivalent is given as R1 plus R2 plus R3, like this. So here you have to find out the equivalent resistance between A and B. Class, this is a very basic and a very easy circuit. Start from here and tell me what's your R equivalent you're getting. Class, look here. These two are connected in series. So R1 will become, this will be 4 plus 8. That will give you 12. So how can we draw our circuit? See, this part will remain the same. But now instead of both of these, we just have single 12 ohm connected with 6 ohm. Here you have 4, you have 8. Now look, they are connected in parallel. So our equivalent will become 12 into 6 by 12 plus 6. And their resultant is in series with these two. It's like their resultant is in series, where all three are in series. So you will just add plus 8 plus 4. So this becomes 12 and this is 4. So it's like 4, 4, 8 connected. So our equivalent will become 4 plus 12, that is 16. Note it down, class. Just text me done in the chat column once you've written. All right, class, those who have completed, you can leave. Now tomorrow we'll just practice questions, because theory part we have studied today a lot. So tomorrow we'll practice questions. Okay, class, thank you so much.